French class. Today is Tuesday, Jan 10. All right, this guy here. With your highlighter, grab a highlighter. Again, if they give you the central angle, a little softer, if they give you a central angle, the only other thing you can get is the radian, the crust. Write down radian outside there just so you start feeling that thing. I know we talked about pi radian. How many are pi radians? Yeah, 3. Whenever you hear pi, it's 3 of them. And those radians are just the radius wrapped around the edge of your pizza. But again, just so you know, if they give you the degree and the instructions are weird, like what do they want me to find, there's only one other thing you can find, and that is the radian. How much crust is associated with this slice of pizza? If they give you the pizza, like the radians, in other words, how do I know they gave me the radians? The minute I see pi, I know it's a radian. It's the crust. And the only thing I can find, even though the instructions here were a little bit odd, the only thing I can find is how many degrees goes along with that crust of pizza that they gave me right there. All right, so let's see how I'll do this guy real fast and I know it's on your paper. We know to go from degrees to radians, you have to multiply by the fraction pi over 180. You got to do it. 3 over 180. If you reduce that fraction, reduce to something. If you're going to go from radians to degrees, you know you got to flip that same fraction, and now pi is on the bottom and degrees are on the top. So whatever you want to end with has to be on the top. All right, so I'll run this guy really fast. I made 290. I won't see whether we do 93 now or make it our review for Tuesday. So this one, standard 1, is guaranteed. Everyone gets standard 1, even if you miss part of standard 2, standard 3. Standard 1 guaranteed. And here it comes. This guy we did last time. You have that 40 degrees. How do you do it? Dimensional analysis. You do your little plus sign. What goes on the top, someone? And of course, the 180 goes on the bottom. The hint will usually be, the answer will be a fraction. 9 out of 10 times when you go from degrees to radians, it's going to be a fraction. Let's see if I can put it here. Oops. Oh, no. My 5, my 180. I have a 40 on the top. You multiply the top, and you divide by the bottom. In this case, you just reduce the fraction. So for those who weren't there today, you're lucky that you get to hear standard 1, the fast version. Hey, what am I going to do with those 2 zeros? Anybody know? Cancel them out. Just for the record, in the case of math, which says, what does canceling out mean? It means you have divided the top by 10 and the bottom by 10. 10 goes into 40 4 times. 10 goes into 180 18 times. But for our purposes, 1 0 on the top or 1 0 on the bottom, you can cancel it out. Once you reduce the fraction, 4 over 18, you won the game. So how do you do it? Make a fraction and reduce. Make a fraction and reduce. That's how you go from degrees to radians. Let me see if I can reduce that thing. 2 goes into the top, 2 goes into the bottom. 2 pi on the top. On the bottom always over
8. No, 9.
9. All right. Take a look at it, see if you're afraid.
Yeah.
Take a look at it, see if you're nervous inside.
No,
All right. So it seems recommendation when you do the work, show the steps, the first plus sign, how it matches up. That way, if you miss something, I can be able to say, oh, you just didn't reduce it, but everything else was good. Or, oh, you put pi on the bottom. All right. Okay. Any questions about this one? Hey, any numbers are popping up like, whoa, where'd you get the... All right. We'll do the reverse. And again, what I'll do in the interest of time, I'll save 93 as the review for the next time if I remember to. But you want to get 93 done. If you need to switch to it right now, go to it. All right, here comes. This one is even better. Going from radians to degrees, because it's all calculator. Multiply the top, divide by the bottom. What does he mean by that? Step 1, if I were doing this guy up here, and I know some of you have it written already. a dimensional analysis plus sign. Dimensional analysis is what I remember it being called from back in 1988 in chemistry in high school. That was my senior year, so 88, 89. Mr. Jackson, so here we go. Pi goes on the bottom. There's the formula there. Let me put it in blue so it's exactly the same. The pi's are going to cancel, and cancel just means we're dividing them into each other. In other words, pi divided by pi is just a 1. And 1 times anything stays the same. So when you hear cancel, just as some teachers get mad about the phrase cancel. No, things don't cancel and just disappear. No, they're being divided into each other. So here it goes. I'm going to cancel them. Don't tell that math teacher. I'm going to cancel those two. And here it comes. Somebody do 7 times that 180, please. 1260. I appreciate that. Over that 11 that's on the bottom. It's possible one day you'd have to do this by hand, but generally any class that has you doing this, you do it with a calculator. How much is it?
14. Oh, 100
The 2 ones?
Yeah.
All right. Now let's say you put down that 14, and I see this. I would probably not have you redo the entire thing. I would say something to you like this. Hey, double check your division on here. What is your calculator giving you? And then hopefully it would pop into the 114 as opposed to like, nope, whole thing's wrong. What is this thing saying? Here's what it's saying. If your central angle, they use that phrase, central angle, if your central angle was 114, how much of this circle would you get? How much of that crust would you get? You would get 7, how should I say it? Of pi, you would get a little bit more than half of it. You get 7 out of 11 pieces. If pi was chopped up into 11 pieces, like this. Let's say you're chopping it like this. Also, this is massaging, depending on, all right. Say you chop it into 11 pieces, 7 out of 11 is how much of pi you get. Again, when you're looking for radians, just so I can say it one time, they're always asking you how much of 3 will you get. And by 3, they're just going to use the pi symbol. You get either 7 out of 11 pieces of pi. It's up here. Oh, thank you. I'll do that then. All right. Pause there. Standard 2. Please write.
I can. You do a lot of mistakes. I got your Oh god, that was such trash.
I can explain how to find. Oh, I got it right below here.
Do you need to like Sherlock? You think it's trash. I do think it's trash. You're trash.
Shh, soft writing, just keep writing.
Okay, cool. Good. Super.
What was that?
Hold on. Okay, let's go. I can explain how to find the sine, cosine, and tangent of radians and... Someone finish that sentence? And what? And degree. I should put up, yeah, I'll finish it, of a unit circle. Anybody know what a unit circle is?
Circle.
Officially, a unit circle is a circle whose radius is what number? Pi is close. The radius, the length of the radius is a certain number. Pi is close. That's even closer. Alright. It's actually a 1. In other words, if I could, wherever you're drawing yours, wherever you're writing in your standard, a unit circle is a circle whose radius is 1 unit. In other words, it could be 1 inch, 1 foot, 1 yard, 1 meter. But when you hear unit circle, and someone said, hey, what's a unit circle? This is a circle whose radius is 1. What's supposed to be the hint? In math, the word unit always means 1. So The unit always means, I guess, ones. Today's lesson, I hope it goes good because if it doesn't, it's confusing. But if it does, step by step, it should be good. All right, they have their. We're going to back up to something you know, then change the name of the thing you already know. For example, we're going to start with the number 3, but then instead of calling it 3, we'll call it pi. Okay, so you know the number 3. Pi is just another name for the thing. So we're going to start in the right-hand corner, go down to the middle, and then we're going to get to the ugly place where they're going to try and make it extra confusing. But again, start with what you know, change the name of it, and then put it in this wacky situation. Here we go. Number 1. I want you to remember, I was going to actually have you draw it, but then, of course, me drawing it last time, I was like, you know what, just make a copy of it and let them have it. Hey, here's your old friend, the XY plane. On the XY plane, they give you coordinates. They ask you to plot the coordinates or graph the coordinates and put the letter next to the dot. So let's do that really fast. Everyone do me a favor. For standard 2, so that you get a free points on standard 2. Standard 1 taken care of. Please plot the point A. Its coordinates are 1, 2. Now, if that doesn't mean anything to you the first time, I'm going to let you struggle with this so you feel like, what's that again? Can you look on a neighbor if they're doing it? Yeah, someone around you is doing it. I'm okay with you looking. This is the very beginning part. So what is it that he wants you to do? He wants you to graph or plot, whatever word means something to you, 1, 2 on this guy here. Let's just see what you remember. Obviously, I'm going to do it in a second, so if you don't remember, no big deal. You'll get to do it a second time. Don't put it in that big circle. You're putting it right here on this little thing here. For those at home, you're plotting it. Ooh, shoot. Will I undo something? Oh, not fine.
Go get some water for now because I'm bored.
Oh, here it comes. Hey, somebody tell me what to do. Shh.
You need to go to the one on the x-axis.
1 on the X, and then do what?
2.
Thank you very much. I go 1, I go up 2. Put my dot there. I'm a winner. Do me a favor, officially put the letter A next to that point.
Do you have to draw the line?
You do not have to draw the line. That's just me showing, reminding. Okay. Do me a favor, go ahead and graph or plot B if you haven't already done so. Again, this is the old stuff. Right now you'd be like, oh yeah, I remember this, whatever. The new stuff, the only thing they're going to do is change the X and give it a new name, change the Y, give it a new name, and then they'll say, please graph cosine, sine. And you're like, graph what? Same idea. Here it comes. What do I do? Someone different to graph B? -1. Go up 2. Take a look. See if you're confused. See if you have any odd feelings. All right. Right now, most of you are about to pass that middle section. Boom. I'm finished. Oh, whatever. All right, here we go. Here we go. Second section. Do me a favor. Oh, I didn't ask for it down there. All right. Second section. Do me a favor. Instead of calling this the X line, instead of calling this the X line, we're going to call it cosine. So the X line is now just called cosine. Instead of calling this the Y line, or the Y-axis, we're going to call it sine. Now sine and cosine have to do, of course, the geometry and the triangle, the right triangle and all that. I'm not going to develop that. I'm just going to give it the names, but there's a lot of whatever you could say about it. Because my idea is this. Show them the steps, let them get the answer. And then later on, maybe explain why it works. Or some other teacher may say why it works. You're like, oh, that's why it works? I know how to get it, but I didn't know. For now, I'm trying to explain why sometimes you get all mixed in and you're like, you know what, just forget it. It's easy, but it's hard to me. All right, here we go.
She tell.
I know. Way to mess it up. All right, so here comes. Go ahead and grab C, cosine, and sine. Please underline those so that they will matter to you. Or if you have a highlighter, you can highlight those two because now you will not be saying X and Y anymore. You'll be saying cosine and sine. How do you know which one comes first? The letter X comes before Y, just like the letter C comes before S. So I'll go ahead and on the second one, Yeah, that's
Is
it.
it better?
Second one, go ahead and graph those two. Don't do anything with the bottom part.
Oh, ABC.
You put it back down for now so that it matches exactly, and then I'll go below the line. And I'll go below the line. All right. Hopefully you feel the same. Hopefully like, okay, that's cool. So that's all we're doing? Yeah, basically. So here we go. If today's lesson is easy to you, that is a good thing. It's gonna be a tricky thing. All right, here we go. Someone tell me how to graph cosine and sine of C. What do I do? What do I do? One and over. There's my and then that is point C. How about point D? All right, so far so good. We did our X and Y. We did our X and Y, and we did our cosine and sine. Now, because that would be too easy for Algebra 2B, the last math class that most high school students here will take, so I'm going to pre-cal. But let me find out, how many of you in here are going to pre-cal next? After this math class, I'm going to do another math class next semester. All right. So most of us, this is the end of the line. Because it is, they're not going to let it be this easy. They're not just going to give you a book. But before we jump into this big ugly guy, let's do one other thing over here. Here's how they're going to ask you the question. Nice, I like that. He's a good friend. Him and Circle go way back. Do me a favor. Please write down the answer to what is the cosine of C. Now this one I'm going to let you guess, and then I'm going to do it so that way if you guess right, at least you're like, oh shoot. What is the cosine of C? Like, what are they even asking? Little hint. Here is point C. To graph it, you have to graph the cosine and the sine. And so here they're asking you, what is the cosine? But they have to tell you which one. Do they want the cosine of C, the cosine of D, the cosine of A? So they're going to say, what is the cosine of C? See if you can put down the number that you think is the correct answer to that. Once we answer it all together, then obviously the cosine of, the sine of C won't be a big deal, the cosine of D won't be a big deal. What I want you to get is, they're always asking for the same stuff, just with different words. Just with different words. And the part that makes math confusing is, when they switch the language, that messes enough of us up. Hey, somebody say it out loud. What is the cosine of C?
1.
Yeah, 1. The first number is the cosine, the second number is the sine. No big deal. Eventually, to make it harder, they're going to make those questions, the answers into fractions with radicals in it. But it doesn't matter. Whatever the first thing is, that's the cosine. Whatever the second part is, that's the sine. And that's where today's lesson will end. All right, do me a favor. Write in sine C and cosine D if you haven't already. This part I am coming around to check. Do me a favor, please. Come over to this section. One at a time. Yeah, let's just do one first. Get the coordinates for point E up there, and then write down the cosine of E. Once you have the coordinates of E, then let me come around. You're dealing with points. This thing is a unit circle. Can anyone say how we know this is a unit circle?
All the things are points.
All right, close. Say it again.
Radius is a 1.
Radius is a 1. You'll notice it goes all the way here to 1. It doesn't go any further than a 1. They chop the 1 into individual pieces. In other words, $1 has been turned into 80 cents, 40 cents, 20 cents. It's a unit circle because again, the radius is a 1. That's as far as it goes. Now, obviously, some of you, and I see you doing it, some of you who are quite comfortable with this, which is such a cool thing because I know this is a tricky topic depending on how it's presented. Some of you have already written in all your E, your F, and your G. But when I come around to check, I'm really just checking for the coordinates of E. And again, you have to find it up there. again, I was going to write it up here as we did it, as we went along, but I decided just to make a copy. Raise your hand if you have the coordinates of E and cosine E. That way I can come around and start doing that. Here it comes. And here. For these, as you write them in, while of course it's true you can write in just a point, do 0 point, whatever. That way, it will look. That's all hand. Don't rush. Just if you happen to be done, sometimes to check a bunch of people, you can take your time doing it. I'm still coming that way.
Right here.
All right, yes,
Oh, I got Alabama lost this week.
I just put on a drop so it's in there.
Yeah.
Right,
Eddie. You don't.
Anybody that didn't check off for this one?
Yeah. Oh, you know.
All right, let's see. There are 1, 2, 3, 4. There's 6, 9, 16. All right, not gonna work. All right, here it goes. Listen, for your partnership, I'm going to ask you all to give part of the answer. So, Max and Alyssa, you'll give me the cosine of E. Roz and Ron, the sine of E. Right here, Marco and Anna, the cosine of E. Sammy and Jose, the cosine of F. Hope and Ashley, the sine of F. Zadie and Sonia, not yet. The sine of F. Richard and Jacob, the cosine of G. I won't do this again. Marcos and Carlos, the sine of G. Why would I say all the names? Say all the names.
Oh yeah, you have an name. I was like,
Yeah.
mine is probably the easiest.
Get ready, here we go.
Really? I'll do it.
Max, Alyssa, cosine of E.
0.4.
0.4. And then just the next one, 0.5. Cosine of E.
0.4.
Cosine of F.
0.6.
Hope and Ashley, sine of F. Sine of F. What is that? Sine of G. I mean cosine of G. Negative 0.6. And last one. Say it again. And the G cosine is going to be? Okay, so there's an important thing I didn't say here. These answers, highlight please with your thing, are exact values. That's actually an important phrase that they're going to use. When they ask you for the exact value, there are two things that you need to do. Now again, I made it a little bit easier than what we're about to do next. The next part is coming up to try and get it to the actual speed that will be on the assessment. Because on the assessment, they're like, hey, this is Common Core. They're about to take the S back sometime in April or May. We're going to give them the top stuff, not the basic stuff. In any case, what does exact value mean? If you're looking on the circle itself, you will notice that the circle every now and again hits a corner. If it hits a corner, then you call that an exact value. So if someone said, how much is it like on the circle right here, you cannot ask for an exact value because it doesn't hit a corner exactly. So there are only a few places on the circle where there are exact values. As a matter of fact, E technically can't even be called an exact value because it's not even on the circle. But my goal was, okay, make it similar, 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 until finally we get to the thing that we really want, which is, hey, what are the coordinates of the points on the circumference of a circle, of a unit circle? Now, the good news is, I'm going to give you a handout where you're just going to pick off the answers. The test format, I think they want you to have them completely memorized, but because some of the numbers they're choosing are kind of random, I'm going to take the chance of having you do your test the same way you're about to do it now, where you'll have a sheet and you just pick it. It's going to make it far easier than it's supposed to be, and at whatever point I get in trouble for that, I'll tell them, hey, the numbers are just random. Why have them memorize random numbers rather than, if they have the resource, would they know where to find the answers? So here we go. We got our answers here. Do me a favor, highlight the other, there's one other point on that circle that's an exact answer that has not been highlighted. We didn't put a point on it. See if you can find that last place where on that circle it hits a corner. Good. I just thought that there are actually going to be 4 additional ones. So here's what I'm saying. For right now, we gave you one up here. We gave you one up here. I even hit this one here. He's an exact answer. There's one more of those. See if you can find that extra one and put a dot there. If you're not sure, look at a neighbor. Neighbor, like, oh, there it is. What are we looking for? Where the circle hits the corner of a box. Some of them will be close, but technically, there's only exact value. That's the phrase, exact value. So what are you doing right now? I'm putting a dot on on my circle where I find at least one more. It turns out, in addition to the extra one that I'm looking for, there are additional 4 that are official on this particular picture. So again, and again, this isn't a big deal. This is just like, okay, can they identify it? Let me see if I can move my picture down. It's going to mess up where everything is. Well, I'll say this. On this bottom half of my circle, can someone tell me where another one is? I did this one, the ones in red, but I want to add some extra ones. Give me a coordinate where I can go, where the unit circle hits exactly somewhere.
0.0.
All right, so this guy here, we got that one here. This is -8 and -6. I thought I heard another one out there. We got the guy up there. We got his friend up here. So I can't reach up there, but he's up there. Got him up here. So we got those 4. There are actually 4 other ones which you might not have thought of. Say it again. I heard 0, -1, 0, -1. Yeah. He hits exactly, and he's a famous one, it turns out. All right, there are 2 more that you can see now. 1, 0, famous. As a matter of fact, for standard 3, it is going to be these points. That's going to make that wavy line, that picture that you're going to have to make up. It's going to be these points, 1, 0. This friend over here, of course, is -1, 0. And at the top, I can't write it in, but at the very top at 12 o'clock, he's up there. The other thing I want you to notice is, if you look at the clock back there, you'll notice that the number 8 and 4 on the clock are in the same position. The numbers 10 and 2 are in the same position. What's true is, on any of these circles, there's going to be a pattern that you're going to have to look for, which is, what guys are in the same position? Okay, who's the same distance down? All right, let's see what we got here so far. They can find the exact values when the numbers are just regular numbers. They can find it when they're decimals. Now let's see if they can find it when it's weird-looking fractions. Here it comes. This is where we're trying to get. The circles that are in 35, 40, and 60 are all the same. In other words, the fractions don't turn into something different. There are only a few fractions that you would have to memorize if we made you memorize them, which I might eventually, but for now, I'm just going to use this sheet to do it. Let's see if I can bring you down. All right. So what is it he's trying to say to them? Take a look at the fractions. All right. Take a look at the fractions that go around. If on the unit circle, there are several places that you have exact values, and that's where these points are. These exact values that are in this quadrant 1, I'm going to have you mark quadrant 1, quadrant 2, it goes counterclockwise. In other words, your clock goes around to the right. This one doesn't. Quadrant 3, quadrant 4. So the deal on this is this. The fractions that are in quadrant 1 just repeat all the way around. Okay. The only question is it going to be a positive cosine? I'm going to put plus cosine when you go to the right, or is it going to be a negative cosine when you go to the left? When you go up, will it be a positive sign? I'm putting in way too much information here, but to get the answer, you're going to see, oh, that's all I need to get the answer. All right. Once you answer a question, don't answer nothing. I'm just going to throw it out. Yeah, we'll throw it out. Here comes someone out loud. What is the cosine of 30 degrees? Radical 3 over 2. Cosine of 30 degrees simply says, what is the first coordinate at 30 degrees? Oh, it's the first fraction. Someone different, what is the sine of 30 degrees? 1/2 is correct. In other words, what is the second coordinate in this, what is the second number in this coordinate? All right, I'm asking it again. If you answer, don't answer again. Let's try some negatives to see if it messes anybody up. Someone, what is the cosine of 120 degrees? Negative half, but if you answer, don't answer again, don't answer again. Negative half, okay.
Only answer one.
Let's try it again for those who are like, okay. Try again. What is the sine of 120 degrees? Radical 3 over 2. This is what they're going to be asking you for the exact value. The thing that's supposed to make it tricky for you is when they say, what is the cosine of 120? You're like, I don't know. Now, technically, it's something you're supposed to be able to put in a calculator, but if you put it into the calculator and actually work it out, oftentimes it doesn't give you the exact value. So when they say exact value, they want a fraction. What fraction do they want? One of them that are on here. In some classes, they have you start memorizing all of those fractions. Now, there is a pattern that I'm going to show you some point where you use your fingers to figure it out. Like, what is the cosine of 30? Your fingers are supposed to be 0 degrees, 30, 45, 60, and then 90. So if someone says, hey, Thomas, what is the cosine of 60 degrees? 60, I just bend this finger here. The fingers on the top tell me the cosine. The fingers on the bottom tell me the sine. Yes. The answer will always be over 2. So here I go. 1 over 2. The cosine of 60 is 1 over 2. Hey, Thomas, what is the sine of 60? Oh, it's a radical 3 over 2. It's always over 2, and the fingers tell you. Let me do it with 30 degrees. Let me do it with 30 degrees. Hey, Thomas, you bend the finger. This is 30, 45, 60. That's the only part you have to memorize, 30, 45, 60. Hey, Thomas, what is the cosine of 30 degrees? Oh, it's going to be radical 3, always over 2. Hey, Thomas, what's the sine of 30 degrees? Oh, it's going to be a 1 over 2. So your fingers get you the answers for these famous ones. They can't get you 120. They can't get you 210. All right. Let's see if they can actually do the answers. Go on your handout to page, what was that page I had you turn to? I had it up originally.
It's 92.
I lost it there. I don't need you. 92. Was it 92?
No, we're supposed to.
No. It's the second handout. Second
Oh,
handout.
never mind. It's not 92.
Not 92.
You don't know how much
There he is.
It was like page
All right.
Yeah.
Somebody tell me the page so I can write it down.
one. Page net.
57. Oh.
Are you dying? Are you okay? Are you okay?
Who's dying?
Oh, shoot. I didn't do one other thing. Let me do it another way. Sorry. I didn't do it another way. That disturbs him. One other way, because they're going to answer this one there. Here goes. Yes, you can answer, but here comes first. Somebody tell me what the cosine is. So on the yellow page, you're on the yellow page right now. Cosine is of 5 pi over 6.
Cosine, radical 3.
Negative.
Yeah. Negative radical 3 over 2. You have to find this, the 5 pi. Let me do it again.
Oh, okay.
Let me do it again. Find the sine of, but if you answer don't again, the sine of pi over 3. The sine of pi over 3. Pi over 3 happens to be here. Now the speed doesn't matter. They found it fast. And the sine is always the second guy. Do me one favor if you haven't written it. Put cosine, comma, sine over one of them so that you'll be reminded that, okay, cosine just means, hey, give me the first one. Give me the first fraction. Sine just means give me the second. So write that down, write that down. And this will be, alright, so what is it he wants you to do right now? He wants you to go to this handout over here and write down the answers to 2 of them. Tangent you cannot do yet. I'm going to mention it so that you will hear it. But these top 2 are the ones I want you to do, like, hey, are the easy, harder, in between. You just take it right off of the chart.
The chart you just did.
Alright, this will come off the yellow pages. Once you have the answer to the sine and the cosine, I'll come around.
That's what I'm assuming.
Correct answer for sine of pi over 2. Yeah, it's just the one. Some people put both of them, but remember, you only get to choose one of the 2. What was the 150? Take a look at it. Easy, harder, in between.
Pretty easy.
I think I got the tangent. All right, I'm gonna come back to tangent in a second.
Right. Jose, stop screaming.
Should I go to the other page?
Please do tangent.
Flip over to see on 58 if they have anything on that back page.
58
Before I eat it up.
has sine.
No, flip the. I want to see it for the 59.
There is a 59.
All right. Do me a favor. Do the sine and cosine on 58. For this guy here, or for both of them, because your sheet doesn't have the negative pi over 7 or the 5 pi over 12, do me a favor, turn those into degrees and let's see what degree it actually is. So change pi over 12 into degrees. Change pi over 7 into degrees. It's just going to want to be a negative. I'm going to tell you what that negative thing, how that operates. So try that. Oh, here we go. Degrees radians, the thing we did at the very beginning of class. Pi over 180, you'll need that fraction, or 80 over pi. But let me say this. For the most part, they're going to put the famous ones. In other words, the 2 problems you just did ahead of these 2, where you just went and you plucked it off, 9 out of 10 times, they do the famous one. Because the famous ones are so easy, you just pluck it off. They might do one of these where you have to do an extra step. What is the extra step? Turn this radian into degrees. They don't say cosine, whatever degree it is, I'm not sure what it is. And then this one over here, this pi over 7, turn that into degrees. I got to tell you what to do with the negative sign eventually, but for now, just pretend it's not there until you finish and make the answer just negative. You've been given the easy part already, so if anything else you're doing right now feels confusing, just don't think about it, don't stress about it, because it's the easy version that I want you to have. And I'm going to try and do something in just a moment. Let me say when you see negative degrees, or when you say see negative radians. Just like Jose just said, instead of normally 10 degrees, you would go up here. You go that way. That's the positive way you go around the circle. And negative sign just says, hey, no, go the other way. In other words, you go down here. There's negative 10 degrees. But here comes the real question. For those of you just here, I'm trying to do this right now.
I have a question.
Let me
I have
say
no idea what we're doing.
Okay, I think you stepped out right when you started, but for now,
Is that a question?
I have
Or is
an,
that
I have an
statement?
excuse.
hold for a moment, because again, I can tell. That's why I tried to do it initially,
So we're
that this section has a lot of different pieces to it, and the most important piece is what you did before. So let me do this. Let me back up one page so that you can remember before all this extra stuff happens.
It's not a philosophy, I'm saying. Yeah, it's not a philosophy.
All right, take a look here. Almost done, almost done. The answer that you got for these two, those who are talking, the answer you got for these two is what I want you to know. The famous ones. If they put one that's not famous, I will put that point on the circle, and I will put the two coordinates. So that if you need to choose the cosine, you can just pick it. And if you need to choose the sine, you can just pick it. So with whatever just happened on that second page, I'm going to leave that alone. Let me do this. Let me give you how to find tan. Now, to pass this section, standard 2, you do not need tan. If you want a higher point score, tan is about to be available to you. But for some of you, it's going to mess with you because you have to write one fraction above another fraction. And then you have to flip and multiply. So I'm just gonna start it off. See it if you want it. Go with it. If you do not, then just don't talk and just watch. Here it comes. On your paper, please write down the following, and this is for everyone, whether you try to understand or not. Tan is just sine over cosine. Whatever you're given for sine, you write that on top. Whatever you're given for cosine, you write that on the bottom. If you were just given regular numbers, it would be easy, but you're going to be given fractions. There we go.
Can't we just solve the fractions and bring it down?
Here we go. I'm going to write it. I'm not going to use the brain power on this.
Wait, Thomas, can't we just turn the fractions that we get from sine and cosine into a decimal?
No, not for the exact. So do me a favor. Here he goes. Sine. Somebody look on your yellow sheet, please. Cosine. All right, someone already did.
okay.
So here's what just happened. Here's what just happened. If they ask you for the tan of pi over 4, what they're really asking you is, hey, please write a fraction where you have the sine of pi over 4 on the top and the cosine of pi over 4 on the bottom. So far, that shouldn't be very tricky. Next step. Please tell me what is sine. Oh, should I got it right over here. What is the sine of pi over 4? I thought I heard Marco say this. Okay. Radical 2 over 2 is the sine of pi over 4. Hey, how do I know that when I look at the chart? Find sine. Oh, there it is.
Is that necessary? That second thing you put?
For now, just to have all the steps on paper you can. But again, only if you get this do you need it. If you don't get it, you'll skip this one on the assessment and still pass standard 2. All right, here comes cosine of pi over 4. Oh, they wouldn't make it the same as 1. Whatever. Okay. So far, so good? The last step is technically, last step is to solve it. Would I give them credit for this?
No, can we not?
No, they won't let you have it for this. Right. So here's the deal. What you would actually wind up doing, the long way. I'm going to do the long way.
Please do.
Because it's not always going to be the same thing. And so you have to flip it and multiply.
Just do this one.
You know what?
Wait, Thomas.
Or we could just use a calculator.
This one. We don't have
It does, and it's a weird one.
Yeah.
All right. So here's what I'm going to do. I'm going to save this piece maybe for... I want to interrupt it with a calculator. So first, let me say this. The answer would be 1. Okay. Why is the answer 1? anything on the top divided by itself on the bottom, it's the same thing. So I'm going to stop on this piece here so we can do some with the calculator. Grab a calculator, please. Grab a calculator, please. Write what's on the board if you didn't write it already. Some of you can already see why I'm not trying to do tangents. It has so much pieces to it.
Oh yes.
Yes. Arlo,
Oh,
I mean, it's going to be on the test, but you don't have to do that one.
what is this Harambe thing?
All right, what am I doing? What am I doing? Calculators,
Harambe's like-
please hit mode. We're near the end. We're near the end. Near the end. Please hit mode on your calculators. Hit mode. On your
Harambe was our
calculators.
A.
I need it.
Then you guys got the sharing here. I think we're enough for everything.
I barely know if I don't read that.
Hit mode. Hit mode. Hit mode. Mode.
Oh, right.
Okay, here.
It should be in radian mode right now. Radian mode.
Can we change it to degree?
No, no, no. You're just gonna keep it in radian. Just want you to have it there. That way, if you say you put it in.
That's it.
I'll share with Aaron.
Sure. Here's what I want you to do.
You have to sign it.
Please punch in sine of pi over 2 into your calculators. So go back to clear, hit clear. Oh, I'm sorry, you hit blue button mode, blue button quit. So you're gonna hit blue button.
This is for Harambe.
You're gonna hit quit or mode.
Wow.
And now what I want you to do, I want you to hit sine pi. Where's pi though? Pi is going to be right under the button clear. If you look right under the button clear, you're going to see a blue pi. You're going to have to hit blue button and pi. Try and punch it in. Blue button and pi divided by 2.
Wait,
Alright, now let me punch it in first and then do it.
we don't know what you're doing.
Yeah, go ahead and close it, and then we'll do it again. I'm going to do it again.
No, it's not.
What was our answer on this one? Alright, so I'm going to do it again. For those who didn't get it this first time, I stole someone's calculator. Okay. So here we go. Let's do this one again. If you didn't get it the first time, do me a favor. Please hit sign. Please hit sign. Oh, on this one, you will need to know how to do this one. There'll be 2 questions on standard 2 that just say, can you punch it into the calculator properly? So this one you do need. So go ahead and hit sign.
Sign of what?
I wish I had it on the board so I can do it on the board.
Didn't you have access to that?
Say again. Then
Yeah, it's like,
Mode to make sure it's ready. Sure it's ready.
Alright, here we go. This one I'm going to come around to see what you have on your calculator. So this second time, we're going to do it twice. We're going to do it twice. So you should have it on there twice, or at least one time on the second row. So step 1, please hit sign.
However, do is 1.
Sign, no big deal. The button sign,
Oh, yeah.
Step 2, hit pi. Where is pi? Pi is just below the button clear. So find the clear button.
Second clear, right?
But you have to hit the blue button and clear to get pi. At least you get a chance to do it once.
All of them?
Blue button and pi. I did something wrong. Divided by 2. I'm coming around in just a moment to see it. Divided by 2.
Anything
Show it next door neighbor. If you're not sure, show it next door neighbor.
inside the parentheses?
It automatically, yeah, it's all inside the parentheses.
Guessing. I don't know.
Right, because all of the stuff here is what you want to take sign of.
Jose.
The question is what?
Divide by. Sorry, I don't have a bigger thing. Oh
Didn't
man.
Lisa text you that?
Uh-huh.
Didn't Lisa text you that?
They're doing weird stuff.
Thomas,
Oh,
I
okay.
have
Like,
to
when she's
Want to see what I can do?
Thomas, there are online TI-84s that you can just put on the board and make them watch.
Yeah, the challenge is you can download it, but it won't download without administrative credentials.
We'll be right back.
All right. So take a look. Show me yours. Show me yours. Oh, let's see. Good. Close parentheses. I'm coming around to check now.
Wait, do we have to close the parentheses?
Try both ways.
I got the same answer.
Okay, then you don't have to, but I normally just do it.
Literally sign. So that
I know I took yours. I know I see it. Show me. All
No.
right, hit enter.
because you wanted to make sure. So if you wanted to close it, see the other parentheses.
I literally mine, but I'm making fun of it.
You don't have to close the show.
You get the same thing. Oh, I took yours. This one's doing whatever. Because I see that, I have 50. No,
That's it. You want to see it?
yeah.
So you're on.
Again, we put it in radians. Radian modes.
Oh, mine is.
Keep it on the down.
Right.
Because I am.
Marco, you did it, right?
No, it's
I don't know how to
I must
They survived, but they're
One person fell. I got accepted council rules. That's all. The word radiant is highlighted. That's how you know it. Sign. Is it about the sign?
Also,
What about so yeah, right now you're good. Low.
Should be 11:36.
You know, radiant is good. That's good. All right. Oh, I'm recording now. Tan of 2 pi over 3. First, I'm going to write it with degrees off of the yellow paper. What is the 36? What is tan of 2 pi over what degree is that one on the yellow page? So on the yellow page, I have to find not tan. I got it.
2 pi over 3 is 1.
Got it right. So step 1, this is a 120. So what this problem is really saying is, what is the tan of 120? I'm just going to be writing down the information. You won't use the calculator on this one. This one I'm just showing you to get the exact answer. Exact value, rather. Just so you can have it in your notes. All right, step 1. Tan 120. I'm going to write it fast. Just equals sine over cosine of the same 120. What is the fraction that goes with the sine of 120? Wait, erase that radical over 2. And let me do one other thing to change the color so that you're just writing this down. So again, radical 3 over 2.
That's a sign.
What is the cosine of 120?
Negative 1 over 2.
So starting it off isn't very difficult. Here comes the difficult part. How do you divide one fraction by another? How do you divide two fractions? The answer will be you just take the bottom fraction, you flip it and multiply. I'm going to do it in a second. You take the bottom fraction, you flip it and multiply. But what does that mean? That means the following. Radical 3 over 2. He's regular. Nothing happened to him. Here comes the 1/2. I'm going to flip him and multiply. That's the big deal. Take a look at it. Again, when you get to the test, if this little move here you can't do, you don't have to do it. So there it comes. I multiply top times the top. Bottom times bottom, I can cancel the 2's for those who are good with fractions. I'll just multiply them and then reduce at the very end. 2 times a radical 3, the 2's on the outside, the 3's on the inside.
On the outside.
You can't do anything an outside with inside, you can't combine them. The bottom is a negative 2. I should have cross canceled.
Oh.
This is only if you want this one on the The last thing that you're going to do, you're going to divide the 2's and you're going to wind up with a negative.
That's the answer?
That is the answer. Write it down. You don't need to have this one. This is just for those who may go for it. They'll have at least some steps they can look at to do a 10. But it starts off with a fraction.
You have it.
Flip it, multiply, reduce it if it
Got
can.
it. Did it.
Let me pause. Let me take a look.